So welcome to the Citrus I4 Energy seminar. I'm Therese Peffer. I'm the Associate Director for I4 Energy. Welcome to the folks that are watching us on the web at the different UC campuses. Just to let you know, there is another I4 Energy seminar this Friday, so November 1st. This is incoming Professor Scott Moura, and it's on electrified vehicle energy management. So please come. It's in the same location at noon on Friday. Big Ideas has launched, so the deadline is November 5th for pre-proposals, and you can find out more. There's information out in the Tech Museum out here. And next week, there'll be a panel discussion featuring top journalists and researchers on the future of manufacturing. That's here at noon to 1:30 p.m. Wednesday, November 6th, as part of the Research Exchange. So with that, I will introduce today's speaker. Alice Agogino is the Roscoe and Elizabeth Hughes Professor of Mechanical Engineering and is affiliated faculty also at the Haas School of Business here at UC Berkeley. She directs the BEST, which is Berkeley Energy and Sustainability Technologies Lab, and is a member of the Berkeley Institute of Design and the Consortium for Green Design and Manufacturing. Professor Agogino served as chair of the UC Berkeley Division of the Academic Senate, and she's served in a number of other administrative positions at UC Berkeley. So please join me in welcoming Professor Agogino.
Thank you. So what I thought I would do is frame the talk in terms of looking at how we define problems that we work on, how we frame them, specifications versus opening them up to the broader cultural issues. So this, and what inspired me to frame the problem this way is the workshop this weekend put on by the College of Environmental Design. It was a workshop on wicked problems in socio-ecological systems, symposium workshop, and I was running the panel on the history, I guess because I was in the over 60 crowd. But the way I framed it was that I was very much inspired by the author of the Wicked Problems inventor, and that was Horst Rittel, who was on the faculty in architecture at the time with a joint appointment with Stuttgart in Germany. And I was a new professor. I joined the faculty in mechanical engineering in 1984, and SF had started a new program in design theory and methods. I'd won a major presidential award in that area. So really jazzed up about design theory and methods. Not many people in my department really did this, and so I reached out to other departments to try to understand how they frame design methods in across the campus. I had John Giro visited me as a visiting scholar as well. Now I've got a picture of my daughter here who graduated a couple years ago just to remind me of the date when she was born and the semester I was pregnant, which was spring 1989. In 1989, they didn't have maternity leave policies. I was the first woman to get tenured in my department, and the campus really didn't have well-known policies, but in particular, my department didn't know how to handle a pregnant female professor. So what they did is they gave me a reduced teaching load with only 2 courses. One of them I would co-teach with other faculty, and it was a wonderful course. It was a course called Social Implications of Technology, which I co-taught with wonderful faculty here, Praveen Varaya in electrical engineering and computer science, and Stuart Dreyfus, who was in industrial engineering and had worked a lot on criticizing, actually, the role of computers in artificial intelligence. And then the other course I was to teach was a seminar course. I ran it on my own, but, it was a seminar course, so I could have guest speakers in case I went into labor in the middle of the semester. And so I arranged a bunch of speakers, including our own Carlos Sakin in ESS, talked about very large-scale integration design, VLSI design in electronics. And Horst Rittel helped me in framing design problems as wicked problems. And so as a tribute to him this weekend, I went down in my garage and got some of the notes from that seminar series, which really put me on the track of thinking about design problems more broadly, wicked problems versus tame problems. So here was one of the slides, and by the way, these were transparencies in 1989, not computer slides. I digitized this one. This one came from a textbook. This is how designers at the time, or engineering designers at the time, defined the design process. You start with a specification that's given to you, and you design for that specification. You start brainstorming, you analyze it, you do detailed designs, you do drawings, you do prototypes, you test them, you manufacture, you ship them, and then you monitor their performance. But the important thing here is that you're given the specifications. That's the starting point for engineering design. But Horace Riddle said, no, in fact, wicked problems never have specifications. And he had published a paper in 1973 with his co-author, Mel Weber, who talked about and defined wicked design. So in 1973, he was well ahead of his time in defining complex social technical problems. And he created all the attributes for wicked problems. For instance, the stakeholders don't agree. There's no best solution. I mean, forget optimization. You're lucky if there's even a solution. But there are just solutions that are better or worse. There's strong ethical, moral, political, and professional dimensions. Alternatives just may or may not be there. There's no objective measure of success, so you don't have those specifications to start out with. And it requires complex judgment. Now, part of looking at wicked problems, Horace Riddle also started talking about what tools would best be applied to wicked problems as opposed to tame problems. He was very much into observation and ethnographic methods or qualitative methods. He was into transdisciplinary design, recognizing that many of these problems require pulling in people from many disciplines. Design as a discourse. Horace Riddle said design is an argumentative process. You know, if he had one sentence to define what wicked problems were, it's argumentative. And he practiced what he preached because he really felt it was important to work with the community and listen and understand the arguments associated with the design challenge. And he also said iterating and prototyping to learn. And that's what it says here, iteration. Every trial counts. Learn from everything you do and then do it again. Prototype and do it again. Now, on the right, I've got what I pulled out, what I learned from how you solve wicked problems. And it looks very much like what today we call design thinking. And so I went back and I traced some of the history of what is sometimes called human-centered design or design thinking. Peter Rowe in 1987 wrote the first book, major book I know of, on design thinking. And he was an architectural professor of architecture at Harvard University. This was really going over various design methods in design thinking, and he really highlighted the ill-defined and wicked problems from Horace Riddle as part of it. There was a design thinking symposium in Delft in 1991, and then Buchanan wrote Wicked Problems in Design Thinking and Design Issues in 1992. I point this out because some of my colleagues across the Bay think they invented design thinking. This is all well before the D School at Stanford. But what does framing problems of wicked problems actually mean in terms of the solution and the techniques? And I wanted to give you one example from a colleague of mine in the design industry, Michael Berry from Point Forward. He talks about an example from the Mono Indians, the Mono tribe, named after Mono Lake, but really Madera counties and Fresno counties in 1923. Black and white acorns were really their bread food, their subsistence in this culture. And the Bureau of Indian Affairs went in to try to improve their life. You know, we're the government, we're here to help you. And so the question is, how do you frame their major problems? And they decided to focus on making a grinding acorn more effective and more efficient. And so this Mono woman is preparing acorn. It turns out it's a very slow and difficult process. She does it she does it on a rock, basically, grinding the acorns in a community kind of setting on the rock, kind of big pestle and mortar. And if you frame it as a use and usability problem, is what the Bureau of Indian Affairs framed it as, and they really focused on function and the ergonomics and looked at this one quote. It is hard, time-consuming job for us. Some of the women would complain about it hurt their back and so on. And they framed it this way, and they came up with a device that cut, I think, the time by 1/10. really an efficient device. They found this solution that you could put the acorn in, you could use a hand grinder. You didn't even have to leave your home and go to the communal grinding place. You could, in fact, grind your acorn in your house. So it took a tenth of the time. It was more convenient. And so as a use and usability study, it was great. And they were very proud of their work, and they gave these out for free. And guess what? Nobody used them. Why didn't anybody use them? The huge social aspects were left out in framing it as use and usability. And so meaning in many, many design problems, particularly wicked problems, are the key. You've got to capture and address the meaning in people's life. And so he used some quotes that might have come from this community. From the village to this boulder, we have always come to sit and work. We sit and pound acorns. We gossip. We scold the children, and we make food for our tribe. The children play nearby, and we can hear and they can hear our stories. So it was a way to communicate the culture to the next generation. To pass the time, we tell stories and sing the songs of our people and how we live. The acorn is mother to us all, and the stone where we give her life, and she gives us life. That stone was a really important part of their culture. So I just use this as an example of when we look at wicked problems, how we frame those problems and where we draw the boundaries of what we're really going to address. Are we going to look at functional needs and specifications, or are we going to go broader and look at the meaning of people's lives? So I was asked to work on a project with the Pinoleville Pomo Nation. Actually, it was an interesting project. The tribal nation actually met with the American Indian Science and Engineering Student Society to help them out. They didn't feel they could help out because they were a little theoretical. One was an astrophysicist, as I remember. And one way or another, they got sent to me. And I met with some members of the tribe. They're located about 2 hours north of here on the map near Ukiah. And they came to us and said, we have these problems. Number one, we've got rising heating and cooling costs. We've got low-income HUD trailer-like houses that have no insulation, and so we're spending what little money we have, and by the way, I think they had something like 90% unemployment. We're spending what little money we have on propane, and this kind of trailer-looking house does not reflect anything of our culture, and they were also worried about the environment and drought conditions. So when I talked to them, I said, do I start with this as, boy, this is an easy project. I just need to go into the Department of Energy, solar energy sizing routines and figure out a good solution to their problem? Or do I step back and look more broadly? And the other aspect of this problem is at the same time, UC Berkeley's Hearst Museum was in a lawsuit with them and many other tribes because of repatriation. So they had a lot of the bones, a lot of the baskets, a lot of the artifacts from various Northern American tribal nations. And so they did have to give back the bones by law. But there was an issue about whether they had to return the baskets or where they kept the baskets and so on. And so there was a lot of tension associated with what can only be called an abused people, right? I mean, it used to be that there was $10 a head on a Northern American Native American. $10 for a dead Indian. Not that long ago, within the last 100 years. So this is an abused culture, and why should they want to do anything with me or trust me? And so that was my first concern. What could I do to be helpful in this situation? And I basically said, we've got to, if I'm going to be helpful at all, it's not going to be to run those, energy programs and figure out how to build a solar home for this community, because when you step back, 90% unemployment, how are the homes going to be built? What is the cultural context? And so on. So I have run what are called innovation workshops that I learned actually from the Anita Borg Institute. If anybody knows Anita Borg, she was a leader in computer science and getting women involved in computer science. But she also believed that you did that by working with communities and showing that computer science could be relevant to people's lives. And so under her, I ran a number of workshops called innovation workshops. in several underserved communities. For instance, this picture over here is an innovation workshop called Seguro that led to the Seguro project, which was to protect farm workers in Central Valley from pesticide poisoning, for example. I had worked with a Latina organization in inner city Oakland to find ways that Latinas could feel proud of themselves and want to go into a science or engineering career. The idea with these innovation workshops are usually a day, although timing and transportation is such they end up being about 6 hours, is number one, we, the people from UC Berkeley, are not the experts. The experts are the users, the people that we are working with. They know much more than we do about what their local needs are. The end users and the designers need to work together to control the idea. So everybody is a stakeholder in the process and needs to feel empowered. Idea creation is done in context, which is why we went up to the tribe to do the work. And it gives agency in the design, development, and implementation that we hope, and it's still kind of open, but we hope self-efficacy of the people that were involved in the process. So the end user experience and the designer experience working together. We set up a workshop with the Pinole-Ville Pomo Nation. We worked with the tribal council to understand how we were going to organize this workshop. I was a bit concerned that with the high respect the tribe had for the elders, that the youth voice would not be heard. So we started out with separating out separate groups of youth, elders, and then the majority population. We worked on ways to at least try to establish some trust at the beginning. I was very grateful that the Pomo Nation has been trying to relearn their lost language, or almost lost language, and one of the medicine men said a prayer at the beginning and at the end, and then we had indigenous food was prepared for us for lunch. So it was really, the tribe just did a wonderful job of setting things up for this workshop. But I do remember at the end of the workshop, I have everybody sit in a circle and say what they learned from the workshop. At the beginning, what did they expect and what did they learn? I remember one guy walking away and said, "I'll believe it when I see it." And I respected that. I think many of you may have been involved in projects where people just come in, they think they're doing something good, and they walk away. So I always remembered that guy, and I wish I knew who he was. I would love to talk to him again and see what he thinks of this project. But that drove me, that I wanted them to believe it. So when we ran the workshop, we found out that the needs, and the whole idea of the innovation workshop is the user, the customers are the experts. We need to understand their needs in their context, and it's usually not the specifications you're usually given. So as you can see, these are the needs that came out of the workshop, which were much different than that list of functional needs about energy that I showed you initially. And what happened was, number one on the list was to learn and to use traditional building techniques. That rose to the top, both with the medium population and the elders. So the cultural values, round shapes and natural materials turned out to be the most important thing to them. Also the technical ones, energy conservation, water conservation. The youth wanted privacy, as many youth do. So the elders wanted, communal kitchens, you can all talk, you can all dance together. Some of the youth really said, well, there's times that we want to be by ourselves. So privacy was an issue. The youth also wanted exercise. There were issues of storage because, for instance, with the tribal dancing, they don't have places to store some of the equipment. Safety was an issue. There had been a death, actually, near tribal lands where someone was shot with a shotgun. Lighting was not safe, and so there were safety issues that came out of it. Comfort, and then lower energy costs, which is what they came in at the beginning as a specification, turned out to be much lower compared to all of these others once we really dive deep into the user needs. Now, one thing that I think is important with the work that we do is that we put it on an academic setting and that there's always a research component, there's scholarship, we publish so that we build on the scholarship of others and we extend the state of the art. Ryan Shelby is a former PhD student of mine. Many of you may know him. He did his dissertation on this topic and how you frame sustainability, Co-designing sustainable communities, identification and incorporation of social performance metrics in Native American housing and renewable energy. And when he framed sustainability with the tribe, he came up with these three elements, which again had not come up in looking at just the specifications. This was the meaning part of this project. Tribal sovereignty was number one. Even today, they don't want to rely on the grid. So actually, having that tribal sovereignty was number one. Economic independence and self-efficacy, and environmental harmony. And the environmental harmony really struck me because when I went into the restroom at their, basically their nursery school, and you know, the little toilets and everything, right in front of the toilet was ideals of the Pomo Nation. And environmental harmony was one of the things that every child sees every day when they go into that center. So in the co-design process, you also learn of values of where people want to go because they're helping co-design. And when they co-design, we were amazed at how sophisticated actually the tribe was. They had done a lot of research on this, looking at maybe how they could use solar and wind energy generation in the houses. I decided to accept the project, and we went further in doing the design, and I actually had a freshman design class. My department questions whether freshmen can do design. I disagree. I think sometimes they're better. They lose their creativity as they move through the academic system. This was a freshman design process for a half a semester class. And I go through a design thinking process where I encourage early prototyping, working with the customer and user, and using low fidelity prototyping. So in this case, you can see the coffee holder as the roof. I think this was the skylight was a used salad bowl container or something else, and balsa wood. And the reason we do this is so the community feels empowered to criticize it. If it had been a sophisticated machine-shopped prototype or sophisticated wood prototype, they wouldn't feel that they could criticize it. So the little pods here were for the youth, the privacy for the youth, but retaining the round features and the features of a communal kitchen and a communal living room for the rest of the house. They opened it up. There were lots of areas for storage on top, and they negotiated about various renewable energy options that they might consider. Now, remember, one of the meaning aspects was autonomy and self-efficacy. And after we did the workshop and after the tribe gave us feedback on some of the early concepts, we went and had another workshop. And as we drove in, we saw this. Now, if you compare the different designs, there's a lot of similarity in the designs. They didn't have anything like this. They had box houses before we did our workshop. On their own, they designed this greenhouse. They went to a local lumber yard and got donation of money for the wood for this greenhouse, and it illustrates all of the features that came out of that workshop. So we felt good about the self-efficacy aspect of the project. One thing led to another. We had various co-design mock-ups. Our original balsa wood mock-up really would have been too expensive, so we had to work with various contractors. There were some mock-ups on the drawings. We worked with the tribe on co-designed in all aspects of the project. This is one of the mock-ups you can see in the Citrus Museum over here on our display here. And here's another one that we did through the School of Architecture. Yale Perez was a student in my new product development class, and this actually, the CARES project actually was one of their projects. Student in my new product development class. And this actually, the CARES project actually was one of their projects. Student in my new product development class. And this actually, the CARES project actually was one of their projects. Student in my new product development class. And this actually, the CARES project actually was one of their projects. Student in my new product development class. And this actually, the CARES project actually was one of their projects. Student in my new product development class. And this actually, the CARES project actually was one of their projects. Student in my new product development class. and this actually, the CARES project actually was one of their problem standpoint, is the tribe made this decision. They looked at their different alternatives and decided that this was in harmony with nature because that was absolutely essential. Solar electric, solar thermal. This is the First Start Center. We were practicing on some inexpensive solar thermal with the kids so that they would understand how you can get energy from the sun. We've looked at microhydro and wind. Those don't look as good. They do own a river, but it really doesn't throughout the year get enough volume to do microhydro, that we're still looking at it in wind. And so what's been the impact of the project? Well, again, when we look more broadly at meaning, the autonomy was important, but so was empowerment and the capacity in green jobs. Now, I don't know how many members of the tribe actually benefited from green jobs, but they sure learned a lot in designing and building this home. I learned a lot. My students learned a lot. The School of Architecture does not teach a course on straw bale homes. We all learned a heck of a lot about natural building materials and architectural design associated with it. We also had workshops, in order to train people, we also had workshops on renewable energy. Not only the adults, but we included the kindergartners as well. And so we had various workshops associated with wind energy so that people would understand the trade-offs and then allow us to monitor. So, for instance, we had anemometers out there that the adult members of the tribe went out and just measured everything there. So we're hopeful that the students were able to develop professional design and communications skills and also aspire to careers in this area as well. And then, as I said, we were able to get both HUD and DOE funding, and the tribe got it, I should say. They were the lead institution in all of this. We're really grateful that the Smithsonian Institute's Museum of American Indians have decided to do a case study on this project, and so we were an exhibit at the museum, and Yvette has back there, I think if you're interested, the handouts that they gave. They made a little case study for it, so you're welcome to have one of the handouts on this project. But basically, if you look at impact, renewable energy systems were co-designed and built by tribal nations, which was one of the things they thought was important. And the rainwater catchment and gray water were also just part of the overall design to reduce vulnerability to water shortages. And then some of the details they had put where the impact areas were in terms of participatory process, adjacent to facilities, tribal building codes, which is a real innovation. We worked with the tribe because one thing about Native American tribes is their autonomy with the U.S. government allows them to develop and make arguments for their own local building codes, which was a real plus, and they see themselves as becoming a leader on green technology building codes. Natural materials of the culture, prototype replication, and then some of the funding associated with the project. So what I'd like to do, this is the home. This is the outside of the home. Nobody's living in it yet because they're still getting approval from the grid, but they've identified who's going to be living there, and they're just going through the approval process now. And I'd like to hear from their words, a video that was made by the Luce Foundation. We won a grant from the Luce Foundation to offer a graduate certificate in engineering and business for sustainability. And as part of that program, my courses, my sustainable design courses, for instance, get funded by that program. We are at the greenhouse of the Pinoleville Pomo Nation, and we're working on building the culturally sensitive, sustainable home that was developed as part of these EBS classes. I use what's called a human-centered design technique, and that means we make the humans the center focal point of any of the building of the design, and then the technology follows. And in that kind of process, we look at all the different legs of sustainability: economic sustainability, environmental sustainability, and then social sustainability. And it turns out on this project, social sustainability.
2007, I took a class with Professor Alice Agogino. It was called Sustainable Product Development. And in this class, we brought together engineers, architects, sociologists, and also some business majors.
So that's us building the house.
With how can we actually create an idea that you could actually turn into a real organization or a real business? How do you actually help people improve their current level of sustainability? These local communities wanted to be able to partner with other organizations to, one, not only quantify their current level of sustainability, but actually start designing and implementing these solutions.
The students came in and did not pose as experts right away, and that allowed the tribe to assert its kind of cultural principles, its ideas about technology, its ideas about social life.
I'm very excited about seeing this project done. I come up here every day and look at it and just think, wow, looking at the hay bales and thinking about the insulation and trying to think of how could, in the future, could we get a little bit greener? I don't know, but it's exciting.
It's a tribe that believes that sustainability is key to very long-term survivability in this country. What do we actually mean by sustainability? Or when they said they wanted energy and water efficient buildings, well, what does that actually mean? Going through this co-design process, we've been able to realize that when they talk about sustainability, it's not just about greenhouse gas emissions, or it's not just about, let's say, embedded water. It's around these concepts of tribal sovereignty, concepts of economic self-sufficiency and environmental harmony.
Being a Native American person, I was raised with a close awareness to the Mother Earth and of our effect. And living here, I've always wanted to be a little more gentler in the way that we live. This project, the house being a straw bale, passive solar, and the water catchment, gray water systems, fits right into a dream that I've always had. It's really important to me that we have a say in the things that we build for our future. We just had a blessing ceremony yesterday. It was the first time my wife and my kids had seen anything. I told my wife, this would be obviously a great opportunity for us to get a little closer to nature. And her first response was, well, how close are we going to get?
We realized early on that one of their criteria for what sustainable housing would be, it means that it has to include usage of natural materials. And we realized that straw bale and also tule was material that they use in some of their traditional homes. So they really want to incorporate a lot of that into these new homes that they're building now. The goal is to show that these homes actually will have at least a 30% savings on electricity usage and roughly a 25% savings on water usage. And the plan is to take this model and then use it to build an additional 2 homes. And if those homes work well, and if we still are saving those energy and water consumption reduction, the plan is to take those designs and expand out to build an additional 23 new homes.
They call Ryan, Uncle Ryan, my kids. My kid wants to be an engineer. Kanala, the one that's here with me today, they played Legos together.
They have a young kid aspiring to go to Berkeley to be an engineer. That's a big thing, and the collaboration has had a lot to do with that. I think Pinoleville feels...
So, why don't I go on, because I know we're out of time, but he was about to say that Pinoleville's there on the cutting edge. They're taking the lead on culturally sensitive, sustainable housing. By the way, Ryan Shelby, I thought it was really interesting, also comes to some extent from Alabama, from an abused minority group. And the tribal nation, when we first met with them, called him white because he wasn't a member of the tribe. He was white, and it was probably the first time anybody had actually called him white. But I think that he really established an empathy because of a shared cultural abuse. So what's next? Well, Yael Perez, the architectural student, decided that part of her research, she felt really empowered by this process, but felt it was limited because people had to go down to the tribe, and it's kind of hard for Berkeley students to drive too far and work with communities. So what could be done to provide cultural value and a sense of place for remote communities through the web and through the community transmitting their own values through various techniques? And so she set up an international competition called Participlace, and Citrus was one of the sponsors. And about a year ago, we had the final awards. And there were entries from all over the world to build a living cultural center. So this is an interactive museum, if you will. They don't want to call it a museum, but it's to capture their heritage, their artifacts, but also continue it to the next generation. And the winners came from all over the world. We had one from the country of Georgia. We had one from Japan. We had one from Chicago. And yes, there was a limit to what could be done to capture a sense of place, but I think the tribe was pleased. This is the one that won the Tribal Award in addition to the Energy Sufficiency Award. A lot of the look and feel of this design looked like baskets. So the Pomo Nation were very proud of their baskets. And so just the building materials and the overall look, for instance, this looks like the bowl of a basket made of natural materials as part of their center. And then the other step, this project, the CARES project, was the project that came out of my Sustainable Product Design class. And Yale Perez and Ryan Shelby were the co-leaders in that project. The idea was first you assess where you want to be in sustainability. Then you go out and you seek advice. And then you implement. Then you live sustainably. And then you go back and assess. So the next step is once we have people living in these new homes, we want to close the CARES loop, assess how they're living, and then see how we can improve the overall process. And so that means doing wicked problem design all over again. Because what sensing technologies will the owners or the occupants of this house willing to accept? You know, with all the stuff about being monitored and everything else that people are sensitive to and should be sensitive to these days, what will be culturally acceptable? So I think we could just see it as a specifications problem. Let's find out how many energy you use, how much water they use, and so on. I think we need to step back and look at it as a wicked problem and really see what fits into the cultural in terms of what we actually assess. And we're also working with the Kashaya Pomo in addition to the Pinoleville Pomo because we never did get off the grid. They wanted autonomy. They wanted independence. And they were small enough that it just, wasn't worthwhile to get all those batteries to be able to be totally off the grid. PG&E had set up so that they could get money back. And so it just wasn't economical. But they want to move forward to phase 2 to figure out how to be totally off the grid and look at the grid in many ways. And so we're working with various groups on power, internet, lighting, electronic entertainment. The Kashaya, they're up at Point Arena, so they're right on the coast, are looking at ways that they can really get off the grid. And so this is an ongoing project. If anybody's interested in working on it, we are taking applicants for the next phase of this project. I think it's an exciting project. And I just want to thank the partners. These are the partners from the Pinoleville Pomo Nation, Leona Williams, Erica Williams, and David Ponton, Angela James, Monica Brown, Deborah Smith, Curry Williams, Don Williams from the tribe. We also had a lot of help from Michelle Baker, who was with the EPA. We were all fortunate to be honored by the Chancellor in winning the Chancellor's Community Service Award. Some members of the tribe are there. And this is also members of the student team, Ryan Shelby, Yale Perez, Cindy, but we had many students, I'd say probably 50 students have come in and out working on this project. And then finally I want to end with thanking Citrus, because they help fund what we call the Native Cares Project, and that's one of the prototypes of the home that you can see in the museum. So thank you for letting us share this project with you, and I think we're open for questions.
So I have a mic. I'll go over here.
So I'm just curious, when you said the grid, you meant the power grid or the internet and everything else?
That's what I said. It was all those things.
All those things. So they don't want to. They want to communicate, but not through. Okay, I just was.
Yeah, no, we're looking at the grid more broadly. There's a project that actually Yale's husband, Yahael Ben David, has taken the lead on, working with Eric Brewer, which looks at internet as freedom. And setting up microgrids for internet communication as well. Internally, yeah. So they're not spied on.
Okay, that's good.
But they're working in Tibet and other areas as well. So it's a wonderful project. Just got funding from Google. So when I did the Wicked Problems Symposium on Saturday, one of the elders in the over 60 panel is Barry Katz. I don't know if anybody knows Barry Katz. He's a historian of design, and he was the first fellow at IDEO. And he raised the question to me during our question and answer period. He said, should all problems be converted to wicked problems? Should we never accept specifications and go backwards? and really reframe it as a more complex problem. And my first impulse was to say, no, there are problems where you can just optimize and plug in the numbers and run your computer software. Take care of those. It's more a question of focus of attention. That some problems are potentially so large and have such large impact, those are the ones that you really should frame as wicked problems. But I leave that up to you. What do you think? Because we've had this ongoing email discussion, Barry and I. Are all problems wicked problems and should be framed as wicked problems because we're not doing them justice if we don't? Or should just the ones that are important be framed that way?
I'll pass for now on the answer to that particular question. But was there any use or value seen for doing sort of a pattern analysis during the design process, especially with a perhaps cross-cultural situation?
Yeah, absolutely. You're talking about Christopher Alexander's work. Actually, I talked to Alexander when I set up that 1989 seminar. He had back problems and couldn't join us, but I really benefited from talking about him. What we did, mostly not to some extent looking at patterns, but I think to a greater extent to show existence proofs, is we went to the other tribes and showed examples of how they had implemented sustainable solutions on their tribes. And so part of the workshop was, in fact, when we were going over what is solar energy, what is wind energy, we had taken examples from other tribes in a very visual way in one of those workshops. And so I think they saw implicit patterns when they did that. It was interesting because all tribes, all cultures change over time. And so we did have an instance where a historian of the Pomo Nation had cautioned us that the Pomo Nation never had round houses. And I grew up in the Southwest, and Navajo didn't live in the Hogans originally. They were religious, more spiritual places. But as cultures evolve, they co-create their culture. It changes over time. And so they thought the roundness was very important today. But going to an older pattern actually would have been detrimental. And in fact, it caused some tension by going to an older pattern and saying, well, Hogans are supposed to be spiritual, you're not supposed to live with them. Well, now people live in the Hogans all through the Southwest. And so I think they're good for inspiration or as examples, but we did have that issue of historical patterns that maybe we didn't want to follow.
Well, going back to the networking, you mentioned internet is freedom, but now there's a large controversy over the NSA spying.
Exactly.
And the BRICS country want independence and are setting up their own undersea cable. So how does this look to the Pomo?
Well, that's why we're starting the project. If you want to work on it. That's one of their concerns, is exactly that. You know, part of it is to be independent and autonomous, but also, are we being spied on? And I think that's going to be true. We've been using the microsensors platforms at Berkeley in our lighting work and our energy work. The question is, you know, you learn a lot about someone if you look at their energy habits. What are they willing to share? So all of that, it's a nexus of all of that. You know, people look at microgrids as electric grids. We're looking at it more broadly. We're stepping back and looking at more broadly as internet grids, electric vehicle charging, entertainment is a big thing. You know, is it satellite? You know, a lot of issues about cable television on the tribe apparently. Cultural events, how much is private? You know, they would like to share it among the tribe, but not reveal it to the rest of the world. So broad microgrids, autonomous microgrids. And so people are interested in working on it. As I said, that's open. We are taking applications for people that want to do volunteer work on that project.
Yes, thank you very much. This is a comment more than a question, unless it leads to a question. And that's, you know, early on in the environmental movement that began in the late 60s and 70s, you know, models were sought for, you know, what are we talking about, you know, environmental sensibilities, and Native Americans were sort of selected ideally, you know, in the imaginary as implementers of the environmental consciousness, which urban celebrants of the environment didn't really have, a connection with. So imaginary figures were construed, and here it sort of comes around to that was a real insight that you do, actually implement environmental and Native American values concretely, and it doesn't have to be some, imaginary figure. Thanks.
Yeah, and as I said, it changes over time. What they might consider sustainability or harmony does evolve. I worked with UNESCO when I was on sabbatical on indigenous knowledge and sustainability. And there is so much that we as human race have forgotten that we used to do. I mean, we used to have mud homes in Egypt that were entirely sustainable, or in Saudi Arabia. Now there are sky rises that are air conditioned with all the oil they have. I mean, it is, we used to have the answers to some of the sustainability questions. We don't want to go back to necessarily living in the earth, although there are some good aspects to it. But there's a lot of indigenous knowledge that we could tap into that we aren't. And that's something that I learned a lot. There was a Pomo word for wind hole, for instance. So when we did the anemometer readings, we did our own because the readings we had from the government were put at airports, which are specifically designed for low wind patterns, right? So when we relied on those, it turns out there wasn't enough wind for energy. We did our own testing, and we're trying to track down where this Pomo word for wind hole actually was. We think we found it. I mean, it's a little bit far from where we're building the homes, but there was an indigenous knowledge there that we would like to tap into.
What resource constraints did you face when you were designing and building these sustainable communities for the Pomo, and how did they impact the way that you approach the problem and approach the user-generated priorities?
I'm so glad you asked that question. We may be crazy, but we saw no constraints. It's always been my philosophy, if you have a good idea, the money will come. So we came working with the tribe, 90% unemployment, zero money, zero expectations of going anywhere. I was concerned that I don't know what I'm doing, how is the tribe going to treat me? Eventually reality kicked in when the original designs, they had hired a contractor and we got the money. I mean, or they got the money eventually. But when we came in, we had zero. We had zero hope. For some reason, the tribe thought that the engineers from Berkeley could come in and do a miracle, and together we did. But we didn't see the constraints when we came in. It was with the philosophy, if you've got a good idea, the money will come. And reality check, we couldn't have completely round buildings because the contractors didn't know how to do that, although with rice straw bale, you can get a lot of round features. So if you look at some of the pictures of the home, there are a lot of round features in the home. But it may be crazy, but I didn't see constraints.
One last question.
Kind of building on that a little bit, in like the wicked problem in design space, when do you start assessing like schedule, and like how did that schedule play out to the solution you guys came up with?
So one of the issues of one of the features of a wicked problem is it has no end. And so this definitely has not ended yet. We didn't see a schedule, and it was actually a problem because the grants ran out. We were always constantly getting extensions. The tribe would have an issue on something or another. And so one of the features of a wicked problem is, again, like maybe not seeing the constraints, we didn't have a fixed schedule. And it was important to take the time to do what was needed to make it successful rather than force it.
Okay, thank you very much.
Okay, thank you. If anyone's interested, let me know. And there's handouts.